Hi, everybody. I'm Wendy C. I'm a Senior Product Manager with Amazon Textract. Today, I'll be introducing you to Amazon Textract, our computer vision, machine learning-based document analysis service. So before we get started talking about the service, I want to describe why we decided to solve this problem. In talking to many of our customers, we discovered that in computer vision, one of the problems that they want vision services to solve the most are documents. Documents still play a vital role in how business is conducted, in the transfer of data, in communications, in record keeping. And here are a few industries that where paperwork still is core to business happening, and there are many more. So documents are very important. And here, I'd like to introduce one document. It is the Uniform Residential Loan Application. It's a common document if you're looking to apply for a mortgage in the US. In 2016, 16.3 million of these applications, which represent many, many pages as they are quite long, were filled out and processed and represented $2.1 trillion in loans originated. Another document is the US W-2 tax form. For fiscal year 2018, it is estimated that 240 million of these will be filled out. And so what we see is that documents are very important to the role of business, and many of us interact with many of the same documents. So let's talk about why we are interested in digitizing as well as automating the analysis of documents. One use case is for search and discovery. If data is locked in paper or images, it's very hard to get this content out. First, you have to index it. Even then, you're limited to basic keyword searches. Another reason why you'd be interested in digitizing and applying machine learning document analysis is to enhance compliance and control. Having a digital format for a paper equivalent will allow you to understand what data is contained therein, identify areas that may contain sensitive information so you can apply the appropriate controls. Another reason is with business process automation, one of the key steps to starting this process is having the documents in a digital format that can be used by downstream systems. How are documents processed today? There are three ways that people tackle this problem. And generally, businesses will use a combination of all three. The first is manual processing. You get a piece of paper, you need to put it into some system, and so you re-enter this data. To scale, many people will try to use optical character recognition, or OCR, which is a simple text extraction so that you can scan documents at scale. But we'll talk about some of the limitations in the next few slides. To build on top of these two pieces, people have developed complex systems, many of which are template-based, so that they are able to process documents that follow a very standard format and be able to capture that information, primarily structured information, at scale. So there are many challenges for processing documents manually. One, it's very expensive, and with that, it's very time consuming. So it takes a long time to get data from a paper or paper equivalent format into a system that needs to consume it. Another challenge is with every step of a data transfer, errors can be introduced. And here's one example of why that's the case. As you can see here, we introduce another tax form, and we show one of the issues with manual processing. If you ask for people, they may give you these 4 results, which is maybe exempt is true, or 28 is true, or CPP, QPP is true, RPC, RRQ is true. And so a lot of forms and law documents take some context to understand, and having manual processing or manual interpretation of this can lead to variable output, inconsistent results, and may require multiple reviewers to build consensus. Moving on to OCR, as I mentioned earlier, OCR, while it is scalable, there are many limitations. I'll show some examples in the next few slides. One, they're limited to simple documents. They have some assumptions about how documents should be read and how text should be extracted. It's one-dimensional. And so what it ends up giving you is a flat bag of words. And I'll describe why that's an issue. And it also has errors. So looking at an example where there are multiple columns on a document, you'll see that if you run this through OCR, the output is different from the input. What was extract data quickly and accurately and no code or templates to maintain has become one line or effectively one sentence without meaning. So there is a gap between the input and the output. OCR does not understand that these are multi-columns. It does not also handle rotated text or stylized fonts well. Moving on to a tables example, what you see here is the output very similar to the previous slide. OCR will read this from left to right, and there is actually meaning that has been lost between the input and the output. It's very difficult using OCR to associate back that 6/30 was an end date and that end date was related to any company. Taking a look at a forms example, output gets worse. Here, not only are you not able to associate John with first or the first part of his full name, you also don't understand that the gender has been marked. And so logical groupings are missed. Those relationships that give text its meaning are also missed, and data is missed when it's not text. Moving on to rules and template-based extraction. One, it has all the aforementioned limitations of OCR. So it is limited by the accuracy and kind of some of the quirks with OCR. And it requires a lot of development in management because templates are brittle, and I'll describe what that means. If you take a look at the W-2 US tax form, it is a form that the Internal Revenue Service publishes. They publish one format. However, many software providers generate these documents for employees. And what we have seen is that there are hundreds of layouts that are possible. And so if you are going to build a template-based system to automate extraction, you would need to find all of these variants and build templates for each one of these. And they may change. Another software provider may decide to start printing W-2s, or they may update their layout, or it may be the next fiscal year and new documents have showed up. And so this is a never-ending cycle of template maintenance and development to be able to capture one form. And here we talk about why it's hard. If you try to automate this using computer vision, you're looking at 4 documents that look fairly similar to the human eye. But when you run this through a model, what you see is that because of how these documents have been captured, maybe it's due to a slight misalignment or some scanning artifacts, you actually see that a computer does not recognize this as being similar at all. The RGB channel on the bottom shows that there's not one pixel in common across these 4 documents that look nearly the same. Given the challenges with how documents have been processed and some of the limitations of the solutions that have existed to date, we've decided to introduce a preview of Amazon Textract, which will provide the ability to extract text and data from virtually any document. Amazon Textract has 3 features. We are previewing text extraction, or what we call as OCR++, which is the ability to not only extract text, but extract the context within which the text appeared, so that you understand that lines end at a certain place and they have certain meaning. We also are expanding understanding to structured data. That includes table and form elements. If you look at a document here, similar to the multi-column document you saw before, what we build or what we extract are blocks. And so we build with a word, and that word belongs to a line, that line belongs to a paragraph, that paragraph belongs to a page. To use Amazon Textract text extraction, you would call the detect document text API. And you can provide an image or a PDF in the format of a blob or a location of an Amazon S3 object. And what you get are the blocks identified and their relationships. For table extraction, you can provide a document with a table. We'll identify that table and identify the cells therein. Not only do you get the cells, but you get the words contained, even if it's multi-line. And so you would use the analyze document passing through table as the feature type parameter to the analyze document API in order to extract tables. For form extraction, what you would pass through is a document that may contain form elements. On a tax form, form element would be something that you can think of as a field or a prompt, which requires an answer or a value. This is also known as a key value or key value set. So for each block, you get the form field name or key and field value and their association to each other. And within each of these, you will get the words that make up a key or a value. For form extraction, you would pass in a document with form elements, and a form element is a field name and a field value. For example, first name being the field name and John being the field value. What we would return is that the confidence score and those related elements. To use form extraction, you would call analyze documents and pass forms to the feature as the feature type parameter. For our APIs, we have synchronous and asynchronous modes. For use cases where latency is critical, synchronous APIs support single-page documents such as images. And this may be appropriate for mobile applications where a user is capturing an image and walking through a flow where that data needs to be returned in real time or near real time. For much larger workflows or for multi-page documents up to 3,000 pages, we have the asynchronous mode where you can pass in you can start your job, get notified when it's completed, and get your results asynchronously. And so going back to the previous examples, what you see when you compare the output and the input is that the original spirit of the information is retained. We acknowledge that there are multiple columns here and that they should be treated differently, and we should extract it in the following structure. Looking at the tables example, you see here that a table is recognized and the words are grouped by their cell. For example, we understand that start date is January 15th, 2009. If you actually look at the bottom right cell, not applicable because this is the current employer, you also see that the cells will be, or the words here will be contained within their cell. So looking at the forms example, what you see here is that we're able to identify that 01 is associated with a month, or MM in this case, and that MM is associated with date of birth. Furthermore, we're able to capture data here that was lost with OCR. that male was selected and female was not selected. And so glyphs are captured as well. So I walked through what the output looks like with Amazon Textract. Next, I want to introduce why deep learning can solve these problems in a new way. If you look at the documents that you may receive, either the ones you capture or the ones that customers send you, you'll see a lot of variation, both in orientation as well as the variety of documents that they send you. If you look at this example, you'll see that the aspect ratio for these documents and the dimensions, they look very similar, but one is correctly oriented and the other is not. If you pass both through OCR, the check will be read correctly or maybe read correctly, and the second image of the receipt would likely return nothing. With deep learning, what we're able to understand is that there is an orientation here, and we need to correct that orientation to be able to accurately extract that information. If you look at documents that have the same document that has multiple structures or layouts, what you would have seen before is that they're very dependent on the template. Once the template changes, and this can be very minor changes, a new template is needed. With Amazon Textract, we are template agnostic. We do not depend on understanding that social security number has to be right here. And if that moves a centimeter, the template is rendered useless. What Amazon Textract does is understand that there are ways to identify that something is a question, something is an answer, or a form field and a form value, and identify that those are related entities without needing to understand that they are part of a specific template. When looking at documents with a lot of variability, be it a form or a check or a receipt or a book, you'll understand that context matters. And with deep learning, we're able to understand and parse the information differently that traditional techniques were not able to allow. And in the real world, what you'll see is that trying to extract data from a document can get quite hard because of how documents are captured, whether they're scanned, faxed, mobile captured, and you'll start to see photometric variations. Here, if you're looking at this document, there's a table, but it also looks like a trapezoid, and sending this through traditional methods may break. They're not quite linear. With deep learning, we're able to segment the document, rectify it in order to prepare it for data capture. And it gets harder with geometric 3D deformations, particularly true with receipts. It's very hard to get a receipt that is not deformed. And so those deformations make it challenging to extract the text. And with deep learning, you're able to use segmentation rectification to, again, pre-process the document for data capture. Going back to the tables example, what we start with is identifying that a table even exists. And we can do that even if there are not explicit boundaries to explicitly say that there is a table. In this case, we're able to identify that these are cells that are related in this row, part of this table. And we're also able to identify tables and understand where the cells are within that table, even if the table cells are variable height or width. In looking at the forms example, what you will see is that there are units that we identify. We understand that these are related units. And from there, we are able to extract further meaning. Our forms detection and extraction capability is also not dependent on rules. Here you'll see a form field sitting on top of a form value. In other instances, you may see the flip, and that's okay. With deep learning, we're able to understand the broader context and see the document as a human would, to understand where there are form fields and where there are form values. And it goes further. As I mentioned earlier, OCR has a lot of challenges with respect to accuracy. And so being able to identify that something is null with its confidence is also important. But with OCR, previously, you could not be confident whether something was missed or something was actually null. Here we will provide that this is where we would expect a value, and we have X confidence that it is actually null. Here I'd like to walk you through a few reference implementations. One pattern we see emerging for Amazon Textract is index and search. So you can take tax forms, credit application, medical notes, what have you. If it's already in Amazon S3, you can simply pass through the Amazon S3 location of your files. You can use Lambda or Batch to call these documents and send them to Amazon Textract to extract text, key value pairs, or tables, and/or tables. And you can send that output to Elasticsearch and search your documents. Another use case that we see emerging is form capture. You can imagine a user taking a photo of a document, sending that to Amazon Textract, getting the JSON output refed into the customer application to show in real time or near real time the extracted data right in a workflow. And that information, once the user has completed their transaction, can be uploaded into a database. Another use case we see is extraction for natural language processing. Similarly, as you did for index and search, you could take your documents and send it to Amazon Textract, run it through NLP, and then send it to Elasticsearch to discover insights from your documents. I'd like to introduce you to a few customers who are using Amazon Textract. So with 3 launch customers, Roche, Alfresco, and Cox Automotive. Some of the benefits of using Amazon Textract include being able to extract your data quickly, accurately, reducing the amount of manual effort needed to get data off of your documents, lowering the overall cost of document processing, and no ML experience required. Amazon Textract is priced by page or images processed. So for example, a 100-page PDF would be equivalent to 100 PNGs sent to the service. We price by feature. We have text detection, table detection, and key value or form detection. And with the structured data detection services, text detection is also included. We have tiered pricing. So our lower tier starts at 1 million pages per month. For customers to try the service, we're offering a free tier for the first 3 months. We will be providing up to 1,000 images or pages for text detection and up to 100 for table and form detection. We are currently in preview in these 4 regions. US West Oregon, US East Ohio, US East North Virginia, and EU Ireland. To learn more or to sign up, you can visit this website. And now let's open it up for some questions.